testing single population mean. Before starting this, let's have a background of this test. So far, we have studied the large sample test. Okay, large sample test. So when we use the large sample, when the sample size is greater than 30. Okay, so there were 4 large sample tests we have already studied. Now, this is a part of the small sample test. Small sample test. Small sample test. Or it is also called as the exact test because it has particular distribution. Okay, so these tests are based on these following distributions: P distribution, then chi-square distribution, and third one F distribution. Okay, so one by one we will study all the distributions and their test based on it. So now we are starting with the test based on the P distribution. There are 3 tests based on T distribution. T test, this one is the first one, T test for single population mean, and T test for equality of 2 population mean, and then paired T test. So we are here. Okay, so now we are going to study the T test for testing single population mean mu naught is specified. This is similar to the large sample test 1. Okay, so let's move further. So now let's have an idea about the T distribution. T distribution is also called as the student's T distribution. Okay, and is used while making assumptions about the mean, and we don't know the standard deviation. So here the population standard deviation is unknown, and we use estimate of it, sample standard deviation of sample standard deviation, and one more term there, sample root sample standard deviation. Okay. Then in probability and statistics, the normal distribution is bell-shaped distribution whose mean mu and standard deviation is sigma. So T distribution is similar to normal distribution. Okay, but it is more flatter and shorter. It is more flatter and shorter than the normal distribution. Let's see through the diagram. This is our regular normal distribution curve. Okay, now T distribution is like this. T distribution is shorter and more flatter. Okay, so this one is normal distribution. So T distribution is more flatter than this. So this one is the T distribution. All the properties are same. It is symmetric, bell-shaped, and all. Okay, but the only difference is T distribution is more flatter and shorter than the normal distribution. So I hope you understand the T distribution. Now application. So there are several tests based on the T distribution, of which first 3 are syllabus, and we are going to discuss it. So these are the major applications of T distribution. An objective and T test. In this lecture, I will explain you T test for testing single population mean. We also solve the numerical examples based on it, and I will give you some examples for practice. Now, T test for testing single population mean. So the hypothesis is what we have to test. H0 mu is equals to mu naught. Mu naught is given. Mu naught is given in the population. Mu naught is given value. Okay, but to compare the mean value with the given value, and alternative hypothesis H1 is it can be any one of these 3. Okay, either it is not equal to mu naught, or it is greater than mu naught, or it is less than mu naught. So any one alternative will be there based on the situation. So if it is not equal to, then we call it as a two-tailed, and if any one of this less than or greater than, then it is one-tailed test. It is one-tailed test. What is the test statistic under H0? The test statistic under H0 is x bar minus mu naught upon small s upon root n. Okay, so what is this quantity now? And now this follows the normal distribution, standard normal distribution. This test statistic follows standard normal distribution. Okay. Now one term is new there, where sample mean square. This is called as the sample mean square. So this is a very important term, and it is in the statistic. So we have to understand this. So it is summation xi minus x bar whole square upon n minus 1. So in sample mean square, there are one observation less. And when we take, so when we take its square root, then it is called as root sample mean square. Okay, root sample mean square. So what is the difference? What is the difference between no, this is not just a sample standard deviation or sample variance. Okay, so now in the next slide we try to understand the difference between the sample mean square and sample variance. So let's try to understand the difference. Sample variance, now we'll come across all the terms, right? So what is sigma square? It is population variance. What is this? This is population variance. And what is capital S square? This is sample variance. Okay, sample variance. So population variance means this is based on all observations in population. Okay, now sample variance means all observations in sample only. Okay, sample. Keep this in mind. Okay, have sample. And what is this? Small s square. So please differentiate between these. This is capital S square, this is small s square. So small s square is called as the sample mean square. Sample mean square. Okay. So now we have to understand the difference between these two. Okay. So according to the definition, sample variance is nothing but summation xi minus x bar whole square upon n. Okay. And sample mean square is nothing but summation xi minus x bar whole square upon n minus 1. There is one observation less. Okay, n minus 1. Now, if you do the cross multiplication, so we get one common thing there. Okay, we get a common thing there. That is numerator xi minus x bar whole square is equals to n capital S square. Okay, so let's call it 1. And what we get here? Here, numerator xi minus x bar whole square is equals to n minus 1 into small s square. Okay, so let's call it 2. If we equate 1 and 2 from 1 and 2, so we get the relation between, sample variance and sample mean square. Okay, so what is that? So it is n capital S square is equals to n minus 1 sample mean square. So just simple arithmetic there. So we can easily get the sample mean square from sample variance. So n s square upon n minus 1. Okay, so this relation we will understand, because sometimes we are given in the data, in the question we are given sample s square is given. Okay, so we need to find out this one, because in the formula the term is sample mean square. Sample mean square, this term is there. Okay, there is never term sample variance in the test statistic. So for that purpose only, we have to remember this formula. Okay, we have to remember the relation between the sample variance and the we have to remember the relation between the sample variance and the sample mean square. Okay, so that's it. So you have to remember this relation. It's very useful relation. Now next, we study one example on this. So we'll do one by one. So a random sample of 10 boys had the IQs 70, 120, 110, 101, 88, 83, 83 again, 95, 88, 107 and 100. So these are the IQs of 10 students. Does this data support that the population mean IQ is 100? So let's solve this using this. This is a how to identify that this is a small sample test and t-test. First of all, you see the sample size. What is the sample size? 10, which is less than 30. Okay, so t-test will be there. Okay, there will be t-test. It is equivalent to large sample test 1. But here sample size is greater than 30. Here it is less than 30. Okay, there sigma is known, but here it is unknown. Okay, so let's see how to calculate. So what is the variable here? X. Variable means IQ. Okay, IQ of students. So what you have to test here? What is the test statistic? What is said there? It is said that the population mean, okay, means mu is equals to mu naught is equals to 100. What does this mean? This means that population mean IQ is 100. Okay, what is mu naught? The given value. Okay, this is the given value of population mean. Against it, what is the statement? So when you are not clear, is not clearly mentioned, then you can take not equal to. So it is not equals to 100. So how you interpret it? Population mean IQ is not 100. Okay, population mean IQ is not 100. Okay, so now we write the test statistic. So what is the step 1? This is the step 1. Okay, step 1. This is the step 1. Now we are moving to step 2, that is the test statistic. Test statistic under H0. So under H0 means assuming H0 true. Always remember. What does it mean? Assuming H0 true. So what is H0 saying? It is 100. So we are assuming that it is 100. And then we go on. So T calculated value is equals to X bar minus mu naught upon small s upon n. This follows standard normal distribution. Okay, so now in this example, the mean value and the sample mean square root is unknown to us. Okay, so x bar we have to find out, small s we have to find out, then we can use this formula. So let's call it 1. Okay, and now we do the necessary calculations. Okay, so I just copy paste these values. So here I copy paste it. Okay. Okay. So at one side we write these values. So here I write xi, here I write xi square. Okay. And what formula I am going to use here? X bar will be summation xi upon n. Okay. And small sample mean square. So this will be summation xi minus x bar whole square upon n. So after n minus 1, after simplification, I can write like this: summation xi square minus n times x bar square upon n minus 1. This is the simplified formula which we are going to use now. Okay, got it? So now let's do this calculation: 70, 120, 110, 101, 88, 83, again 83, 95, 88, 107, and 100. Using the scientific calculator, you can easily find out the totals. Okay, because we are requiring the total. So now I directly find out the total using the scientific calculator. Okay, so I have calculator FX 991 MS. Okay, so just a minute. So there should not be any mistake in the calculation. If there is a short mistake, then only. So you have to very carefully do the calculations. A little mistake can make great changes in the problem, and you can get the wrong value. So this one is 944. Okay, and now I get the totals. I get the totals directly over here. Okay, so 70 square, using the scientific calculator, you can do this directly. Okay, 120 square plus 110 square plus 101 square plus 88 square plus 83 square plus again 83 square plus 95 square plus 88 square plus 107 square. The value will be big, and 112. So equal to this, and you will get a number. And that number I'm writing here, which is 101341. So this is the number, sum of the squares of this number. So I put these values over here. Okay. So first of all, I find out the arithmetic mean. So what is the value of n here? How many observations are there? Here, 10 observations, right? So this is 944 divided by 10. So it is 94.4 is the mean, sample mean. Okay. Now I find out the formula using this formula. Sample mean square using this formula. Okay. For a summation exercise square, it is 101341 minus n is 10 into x bar is 94.4 whole square. Okay. Upon n minus 1 means 10 minus 1. So get the numerator. It is 10 into 24.4 square. So the numerator is 122 equal to 7.4 upon 9. So you are getting it sample mean square as it is 1358.6. If you take the square root, then you will get the root sample mean square, right? So it is 36.8591. Okay, so always write to 4 digits, right? Okay, so now we have obtained the values. So we will go back to the formula. Okay, so we'll take the fresh page here. Okay. So what was the value there? It is 94.4. Okay, these values were there. So it was 94.4 and 36.8591. Okay, so let's solve this. So using 1, put in the formula using 1, the calculated value we can get using this formula, x bar minus mu naught upon this one. Okay, so put the values here. Now it is x bar is 94.4 minus mu naught is 100. It is 100 upon, what is this? So we have written the value. So we have written the value there. So it is 36.8591 divided by root of 10. Okay, so get the values there, then it will be, so numerator will be minus 5.6 and upon, we will find the denominator 36.8591 divided by root of 10. So this will be 36.8591 divided by square root of 10. So this value will be 11.6558. Okay, so finally I get the calculated value. So minus 5.6 divided by answer. So what I get? So I get, it is minus 0.4804. Okay, so this is the calculated value. Okay, next step, we have to get the table value. Okay, so to get the table value we need two things. First, alpha, level of significance. So what was the alpha given here? So alpha is not mentioned. In case you take alpha is equals to 5%. Okay, whenever you are not given it, you take it 5% by default. So alpha is equals to 5% left. Okay, and then one more thing you need, degrees of freedom. Degrees of freedom. Now this is the new term to you. We call it in short DF. It is for one variant data. One way data, it is n minus. So n is the number of observations. So it is 10 minus 1. So degrees of freedom here is 9. Okay. So now you can easily get from the statistical table, using statistical table for t distribution. Okay, so you can easily get the table value or the critical value. Okay, so table value, or you can say it critical value. So from table, the critical value is, what is the way of writing this? The way of writing this is alpha. Okay, it is written like this. Degrees of freedom and alpha percentage. Okay, it is degrees of freedom, alpha percent, favor of significance. So in this case, it is 9 and 5% or 0.05. So I can directly tell you the value. So how to see that? In the table, in the first side, you are in the first column, you are doing degrees of freedom, and here alpha values are there, and you have to see first of all the degrees of freedom over here, and alpha is 0.05 mentioned here. So the intersection of it, whatever the value intersection of it. So from the table I can see it is at 9 degrees of freedom, and for 5% I can see the value 2.262. So what is that value at the intersection? It is 2.262. Okay, so it is 2.262. Okay, so this is the table value. So you have to compare the calculated value and the table value. Okay, so from the table, now comparing both the values. Okay, so comparing both the values, what we get, we observe that calculated value is less than the table value. Okay, calculated value is less than the critical value, you can say. Don't get confused. Table value means critical value. Okay, so says, so what is the decision when, because minus 0.4804 is less than this one, right? So in that situation, we accept the null hypothesis. We accept the null hypothesis. So when we accept it, then we write the conclusion we have written. Okay. So when we accept H naught, then we say that the population mean IQ is 100. Okay. So when we accept it, then we say that, or we come to the conclusion now. So conclusion is population mean IQ is 100. So that is verified. So the population mean IQ of students is 100 at 5% level of significance. Okay. So this is the problem. So in this way, we can solve this problem. Okay. So, and there are the homework for the practice. So these are the problems. Okay. So thank you very much. I hope you understood this problem. You have to solve these problems in the same way. Okay. So I will help you to some extent. I will give you hint for solving this second problem. Okay. So in a sample of 20 women enrolled in a health program shows mean diastolic blood pressure 99 and the standard deviation, sample standard deviation. Okay. See here, here is the sample standard deviation given. Okay. So here, what is the variable? Mean diastolic blood pressure. Okay. So, and what is the sample size? It is 20. It is less than 30, right? So here t-test will be used for single population. How many population? Only one population, right? And one more thing, what is given here? Sample size is given, then mean diastolic blood pressure of 20 women. In the sample, 20 women are there. Then mean is found to be 99 and sample standard deviation. What is this capital S? Sample standard deviation. You have to remember. Okay. Sample standard deviation is given as what? 32. Okay. So now let's check what we have to do. So what is the claim? Can you conclude that women enrolled in the program have diastolic blood pressure greater than 75? Okay. So what is the claim? Okay. So mean diastolic blood pressure is greater than 75. So what is the given value of population mean? It is 75. You have to compare with it, right? So mu naught is 75. So now we set the hypothesis. So first step. So what you have to test over here, H naught, it is mean diastolic blood pressure is 75. We write in the notations. Okay. So mu is equals to mu naught is equals to 75. That is mean diastolic blood pressure is 75. Okay. And against it, what is the alternative hypothesis? It is now it is given in the claim only greater than 75. So you have to write that one. Okay. You have to write that only. Mean diastolic blood pressure is greater than 75. So that only you have to write. So mean diastolic blood pressure is greater than 75. Okay. So that will come handy when you write the conclusion. Now next step we'll do is test statistic. Okay. So test statistic under H naught. That H naught means assuming H naught true. What is the formula? Now our formula, watch carefully. Our formula is calculated value of t is equals to x bar minus mu naught upon sample mean square root and on n. So this follows standard normal distribution. Okay, so this is our formula. But one thing we are observing, we are given the sample standard deviation, but in the formula there is sample mean square root. Okay, so here we have to use the relation. Here we have to use the, let's call it 1. Here we have to use the relation between sample standard deviation, means that relation which we have proved here. This relation we have to use. Okay. This relation will use sample mean square is equal to n square upon n minus 1. So this relation will use to the calculation. So let's find out here itself. We know what is the relation? Sample mean square is equals to what? N capital A square upon n minus 1. Okay. So let's put the values over here. So n is 20 because 20 women are in the survey. S is given as 32, so it's square here. And n minus 1 means 20 minus 1, there will be 19. So if you solve this, you'll get the value of sample mean square. So 20 into 32 square, so divided by 19. So this value comes out to be 1077.89. Okay. So next page, continue. So we want the sample mean. So let's take the square root. Taking square root. So what do we get? Take the square root of that value. So sample mean square root is 32.8313. So this is the value. So this is very also important question. Every time it is not given the raw data. Sometimes you are given the summarized data like this, and we have to find out. Okay, any query? Okay. So now put in the formula. So calculated value of t is equals to now x bar. We need to check the values. What is given x bar? X bar is given 99. Sample standard deviation is 32. Okay, so I have to remember this. Mu naught is 75. Okay, mu naught is 75. So x bar is 99 minus 75. because mu naught was 75 upon square root, no square root. So upon 32.8313 upon root of 20. So first of all, it is advised from my side. First of all, you solve the numerator denominator. Okay. So 32.83 divided by root of 20. So that value comes to be 7.3413. Okay. And when you divide it, then you get the calculated value 3.269. So this is the calculated value. Okay. So next step will be at alpha is equals. Now alpha is not mentioned. Let me check. No, alpha is not mentioned. So if alpha is not mentioned, you take it by default 5%. So at alpha is equals to 5%, say we are assuming, and degrees of freedom. Now it is n minus 1. So it is 20 minus 1 is 19. So you can get the table value, right? So how we write it? Degrees of freedom at 5% level of significance. This is T 19 0.05 because 5%. So this is the way of writing. So the table value is, now I can tell you again. So you can easily get it from the table net. So for 19 degrees of freedom and 5% level of significance, the value is 2.093. It is 2.093. Okay. So now you have to compare both the values, or call it 2 and 3. So this is the calculated value. This is the critical value or table value. Compare this. What we get? Comparing, we get, or we observe that calculated value is far greater than the critical value or the table value. Okay. So in this case, when calculated value is greater than the table value, so we reject H0. We reject null hypothesis. So when we reject null hypothesis, it means we are accepting H1, alternative hypothesis. Therefore, we have to put the conclusion. So what is the conclusion over here? So let's check. So we have already written mean diastolic blood pressure is greater than 75, right? So that is evident because sample gives 99 and this is 75. So obviously it is greater than 75, but we have to prove through a scientific procedure. So this is that. Therefore, mean diastolic blood pressure is greater than 75. So this is our conclusion. Okay. So that's it. So we solved the two numerical examples here and hope you understand it. Now, this is the example for your practice. So please take the screenshot and solve it. Okay. Check your answer. Thank you very much. We will see in the next. Now we will see the next test. That is the T test for equality of two population means. Okay. So thank you very much. Good.